Okay, so very warm welcome to all our viewers. We are once again back with a new topic, which is the Runge Kutta method of fourth order. I guess based on the intro itself, you might be having some idea of what this topic really is. Okay, this is yet another topic in the numerical methods or numerical analysis subject. Okay, so before we jump on to this topic, I would request you to please revise the earlier methods of solving ordinary differential equations, which is the Picard method or the Runge-Kutta method of second order, because that will be really helpful. Okay, so let's just jump on to this topic now. This Runge-Kutta method of fourth order was discovered by two mathematicians actually, Carl Runge and Martin William Kutta. Okay, I don't know if I'm pronouncing the name correctly. I'm sorry if I'm not. Okay, but let's just jump to the method. Okay. Okay, so as you can see, this method is again used to solve an ordinary differential equation. Well, the prerequisite is, let us consider, let the given differential equation be dy by dx, which is equal to a function of x comma y with initial conditions y is equals to y0 or y0 when x is equals to x0. Okay, then to find the value of y, we get it is equal to y0 plus k at x is equals to x0 plus h. Okay, based on this we can calculate the following terms. Okay, based on this we can calculate the following constants. Okay, so now in this case of fourth order we don't have two values such as compared to the previous second order where we only have had two values of k1 and k2. Now we have four values. Okay, k1, k2, k3 and k4. Okay, what's the value of k1? K1 is equals to h into function of x0 y0. K2 is equals to h into function of x0 plus h by 2 and y0 plus k1 by 2. K3 is equals to h into function of x0 plus h by 2 and y0 plus k2. Okay, and oh sorry, it's k2 by 2. Okay, and k4 is equals to h into function of x0 plus h and y0 plus k3. Okay, in this last term you need to remember that there is nothing in the denominator. Okay, we don't have h by 2 here. Okay, or k3 by 2. That's one thing we need to remember. And lastly we calculate the average of k, which is equal to 1 by 6 into in bracket k1 plus twice of k2 plus twice of k3 plus k4. Okay, then the required value of y is equals to y0 or y0 plus k. Okay, so this is the basic formula which we are going to use under the RK fourth order. Okay. Okay, so let's quickly take an example which will help us to understand this method more clearly. Okay, here we have in this question, apply RK method of fourth order to find approximate value of y at x is equals to 0.2 if dy by dx is equals to x plus y square, given that y is equals to 1 when x is equals to 0. Okay, and the value of h is given as 0.1. Okay, just in case if the value of h is not given, then we will have to take a suitable value. Okay, I'll let you know this at the end of this video. But in this question, one thing which we need to remember, that is when x0 is equals to 0, then y of x0 is equals to 1. Okay, that is the most important thing. Okay, so here we first of all calculate the value of function f, which is a function of x0 y0. Okay, we substitute the value of x is equal to x0 and y is equals to y0. Based on that we get x0 plus y0 square is equals to that the value is equal to 0 plus 1, which is equal to 1. Okay, based on this we can easily calculate the value of k1 because we have the formula k1 is equals to h into function of x0 y0. We get h, the value of h is 0.1 into the value of function x0 y0, which is 1. Okay, so the value of k1 which we get is 0.1. Okay, then again similarly based on this formula itself we calculate the value of k2 as well. Okay, for k2 we have a formula h is k2 is equals to h into function of x0 plus h by 2 y0 plus k1 by 2. Okay, h into function of x0 plus h by 2 and y0 plus k1 by 2. Okay, so we substitute these values, we substitute all of these value, and we get the answer of k2, which is equal to 0.11525. You can pause this video and go through all the steps which are listed in this slide. Okay, similarly we calculate the value of k3. So again for k3 we substitute all of these values in this formula, which is equal the formula for k3 is equal to h into function of x0 plus h by 2 and y0 plus k2 by 2. Okay, we substitute all of these values and we get k3 is equals to 0.11686. Okay, you can pause this video to understand how the calculations are done. Okay. Again for k4 we have the formula h into function of x0 plus h and y0 plus k3. Okay, we substitute all of these values and calculate the answer, which is k4 is equals to 0.13474. Okay, now we need to take an average, value of k, which is equal to 1 by 6 into k1 plus twice of k2 plus twice of k3 plus k4. Okay, we substitute the value of k1, k2, k3 and k4 and we get the value of k is equal to 0.1165. Okay, based on that we can get the approximate value of y. How? Because we have the formula y is equals to y naught plus k, and so we have substitute the values and we get 1 plus 0.1165, which is equal to 1.1165. Remember that this is the value of y at x is equals to 0.1. Okay, now because in the question we have to find the value of y at x is equals to 0.2, we repeat all of this process, but here the values are going to change. In the now the value of x0 will be 0.1 and the value of y0 will be equal to 1.1165. Okay, the value of h will remain same, which is equal to 0.1. Okay, again we find the value of function x0 y0. We substitute the value of x is equals to x0 and y is equals to y0. We get 0.1 plus whole square of 1.1165. Okay, the square of 1.1165. Then the final answer which we have is a function of x0 y0 is equal to 1.3466. Okay, based on this value of this function we again calculate the value of k1. So by substituting it in the formula we again calculate it and the value of k1 is 0.13466. You can pause this video to go through the calculations. Once again we use the formula for k2, which is equal to h into function of x0 plus h by 2 and y0 plus k1 by 2. We substitute the value of x0, which is equal to 0.1, and we substitute the value of y0, which is equal to 1.1165. Okay, and the value of h is 0.1. Okay, so we substitute all of these values and we calculate k2 is equal to 0.15514. Okay, this is the value of k2. Again we use the same formula and same method and same steps for calculations to find the value of k3. And lastly for k4 we use the formula h into function of x0 plus h and y0 plus k3. Okay, we substitute the value of x0, y0 and h and k3 to get the value of k4, which is equal to 0.18233. Okay, finally we take the average, the value of k, which is equal to 1 by 6 into k1 plus twice of k2 plus twice of k3 plus k4. Okay, we substitute the value of k1, k2, k3 and k4 and we get k is equal to 0.1571. At last we need to find the approximate value of y, which is equal to y0 plus k. We substitute the value of y0 and we substitute the value of k, which we have just calculated, which is equal to 1.1165 plus 0.1571. Okay, so the value of y which we get is 1.2736. Okay, this value of y is calculated when x is equals to 0.2. Okay, so that's all. This is what we need to do in this question. I hope you'll like this video. This is how the Runge-Kutta method of fourth order is used to solve the differential equations, ordinary differential equations. Thank you so much once again, and please subscribe to this channel for more such videos.